The improvements made in tornado tracking and research in the United States of America. Presented by Stephen Kidd. This is a short introduction for the presentation to come. Beginning at a very early age, I was fascinated by the tornado. It was amazing to me how something could be so neat to look at with the eye, yet so destructive. Over the years, I've seen how, though they are amazing sights to behold, the tornado is fierce, destructive, and very unpredictable. Meteorologists and storm trackers have marveled at the sheer force of these weather happenings for decades. It's clear that historical tornadoes on record were notorious for being very destructive, fatal, and most of all sudden and unexpected. Over the years, tracking and research has been performed to minimize the surprise factor of these weather monsters and ultimately allow communities to have somewhat of a warning that they're in real danger. I plan to enlighten each of the viewers of this presentation on how destructive these tornadoes have and can still be, but how over the years the research done is greatly reducing the element of surprise. These warnings, if caught early on, can greatly reduce the chances of human injury and fatalities. I've titled this slide Wreaking Havoc. This is just one of the images that I found to be just incredible, really. You get the lightning and the funnel cloud. But tornadoes have been historically fascinating, deadly, and most of all unpredictable for years. So let's take a look at a few examples. The first tornado we'll take a look at is the Tri-State tornado. Killed almost 695 people, injured 2,027, traveled for more than 300 miles through Missouri, Illinois, and Indiana. That's how it got the name Tri-State. On March 18, 1925. It was rated an F5 at the top of the Fujita scale with winds of 260 miles an hour. The second tornado we'll look at is known as the Natchez tornado. The Natchez tornado killed 317 people, injured 109 on May 6, 1840, along the Mississippi River in Louisiana and Mississippi. The official death toll may not have included slaves, according to the Federal Emergency Management Agency. As you can see in the picture, it's just looks like some type of a house or business just destroyed and a man walking on top of it. Just another example of how destructive these storms can be. The next one we're going to look at is the Tupelo Twister. The Tupelo Twister was estimated to be an F5, the most destructive class of tornado, with winds in excess of 261 miles per hour. Some reports noted that the wind was so strong that it embedded pine needles into the trunks of trees that managed to stay standing. 200 people were killed in this devastating tornado. Here's just a picture of what's left of a community. Got some cars out in front of the houses, but everything was leveled. So another example of the destruction that these storms can cause. One day after the Tupelo Twister, there was another tornado in Gainesville, Georgia. These two sister tornadoes spun towards Gainesville. This time it hit both residential and downtown buildings at the start of the workday, which made it even more likely to be fatal. 203 people were killed as a result of this tornado. And as you can see, just again, buildings destroyed, people just looking on to the destruction that the tornado caused. Those were a few examples of some just historical tornadoes that destroyed towns and communities and killed many people. So you can see tornadoes have been extremely deadly in the past. The following slides will show that though great strides have been made to reduce the number of fatalities due to tornadoes, they are still unpredictable and fierce. These next slides are proof that those who invest their time into tracking and predicting, though much improved, must continue to find new and improved ways to warn us when these things are coming. And we'll start with some of the more recent tornadoes that proved to be fatal. This is some images of the 1999 Oklahoma tornadoes. The image on the left was caught as the tornado was ripping through Anadarko, Oklahoma. You can see some of the just devastation on the right image. This particular group of storms killed 141 people, proving that even as recent as 1999, though we've improved with the research and the warnings, it's impossible to keep these storms from doing what ultimately they're going to do. So this next slide is just an image from the Joplin, Missouri massacre. As recent as 2011, it was actually on May 22nd. The city of Joplin, Missouri was impacted by a F5 tornado. 158 deaths with over 1,000 injured as a result of the tornado. This is proof that even with proper warning, these storms are so vicious and capable of total disaster. And you can see trees just snapped in half, and there's nothing left of the community. So this was probably the most recent with a death toll that high in 2011. So. And before we dive into some of the advancements we've made in research and tracking, I just wanted to kind of give you guys an overview. Tornadoes are one of nature's most violent storms. In an average year, about 1,200 tornadoes are reported across the United States, resulting in 80 deaths and more than 1,500 injuries. Forecasting of the tornadoes and other severe storms by the NOAA scientists has had varying levels of success throughout the years. The NOAA's National Weather Service and its predecessors have predicted and warned communities of these severe weather threats with ever-increasing accuracy, saving countless lives and billions of dollars. Some of the early advances, just to give you guys an idea of when this, research and tracking started. In 1882, after nearly 300 years of numerous observations and stories of whirlwinds, cyclones, and tornadoes, U.S. Army Signal Corps Sergeant John P. Finley was placed in charge of the investigation of tornadoes and the development of forecasting methods. During a tornado outbreak that occurred on February 19, 1884, Finley established 15 rules for early tornado forecasting. In 1888, Finley published these rules, which identified signs that the formation of a tornado was likely. We had mentioned the tri-state tornado that killed, over 600 people. Alfred J. Henry, the editor of the Monthly Weather Review, described the conditions that occurred in that tornado, and 9 of the 15 rules that were listed by Finley appeared in Henry's analysis. So Finley's work that was briefly described in the last slide, his work did thus enable forecasters at the time to recognize the possibility for tornadoes, although they were not able to predict the twister in advance. So 9 out of 15, that's amazing for such early on research. It's not too bad. It's actually kind of odd. The word tornado for a long time was frowned upon. Not exactly for sure why, but even after the tri-state tornado, that word continued to be ill-advised and thus deterring tornado research. So just the idea of the word actually kept people from looking into it further. But in 1942, the central areas of the country experienced a large number of tornadoes. Reports indicate that 132 tornadoes killed 223 people and caused just over $7 million in damage. This destruction pointed to the need to warn the public on the possibility for tornadoes. So this was some expanding knowledge that we were getting into. In the spring of 1943, the Weather Bureau formed experimental tornado warning systems in Wichita, Kansas, Kansas City, Missouri, and St. Louis, Missouri. In June 1944, reporting by local weather observers was expanded to include tornadoes, thunderstorms, hailstorms, lightning, and high winds. Forecasters could make advanced weather forecasts indicating that conditions were favorable for severe storms over a general area, but they could not give in advance an exact time or place where weather might occur. Tornado forecasting and research continued to grow with a couple of guys by the names of Fallbush and Miller. This is just a picture of some of the airplanes that were literally thrown about like toys by that specific tornado on Tinker Air Force Base on March 20th, 1948. We had some major breakthroughs that occurred in the late 1940s when Major Ernest J. Fallbush and Captain Robert C. Miller of the U.S. Air Force worked on observational and experimental techniques for predicting severe storms and tornadoes. This particular tornado that struck on the 20th of March in 1948 on the Air Force Base in Tinker Air Force Base in Oklahoma City destroyed 32 military aircraft, and it caused $10 million in damage. So that just gives you an idea. Keep in mind this was on March 20th, as these guys were kind of learning more about what they were looking for with the tornadoes and these storms. So 5 days later, Fallbush and Miller recognized a similar weather pattern establishing itself over the southern half of the Plains states. Based on their observations, the first tornado forecast was issued, and a tornado safety plan for Tinker Air Force Base was put into effect. A tornado ended up striking the base again just after 6 p.m. This time the tornado caused $6 million in damage, but nobody was killed in the forecast, and the safety plan were considered successful. So only 5 days after the tornado ripped through the Tinker Air Force Base and destroyed so much, just with the addition of the warning and the heads up, they were able to greatly reduce the damage and the casualties. So this warning plan and safety plan was definitely a big success and a great improvement in tornado tracking and warning. Here we're going to discuss the Tornado Project. I think a lot of current viewers and modern aged people are familiar with the radar system, which is obviously very important. But developments and advancement in the application of radar were actually made during World War II to detect enemy warships and aircraft. While attempting to detect these things, they would pick up and their images would be obscured by the rain, which introduced the possibility of using radar in weather forecasting. So it was actually kind of not really an accident, but they were looking to find enemy warships and use this radar in the war scene, and as a result of that, we're able to identify that they could use it for weather forecasting also. So that was kind of a neat find for weather forecasters and people that were in research for weather. So the Tornado Project was conducted across Kansas and Oklahoma in 1950. It included an observational network of 134 stations, 34 cooperative stations. Radar coverage for the project was provided by the Weather Bureau in Wichita, Kansas, and Norfolk, Nebraska, and by the Air Weather Service at Offutt Air Force Base near Omaha, Nebraska, Sherman Air Force Base near Fort Leavenworth, Kansas, and Vance Air Force Base in Enid, Oklahoma. The sounding analysis of data from the radio sondes and Roland sondes that started with the Tornado Project became a principal forecasting tool. We discussed some more continued research. These storms just continue to rip through the United States and cause so much death and destruction. As a result of some of the tornado outbreaks in Missouri, Arkansas, and Tennessee around 1952 in March, it killed over 150 people, led to public outcry and congressional pressure for the issuance of tornado forecasts. As a result, the Severe Local Storms Center was established within the Weather Bureau in June 1953. They developed a checklist for forecasting tornadoes that included the basic parameters founded by Fallbush and Miller, who we mentioned earlier. And obviously there was something to that checklist of 15 things because it was actually renamed the Lifted Index. It became the basis for evaluating potential instability for many decades to come. Along with a lot of the research that was being done, they had to find a way to be able to track and gauge these storms known as tornadoes. So they came up with the F scale, or the Fujita scale. It starts out with F0, which is light damage, F1, moderate damage, F2, considerable damage, F3, severe damage, F4, devastating damage, and then F5 would be incredible damage. And then as also on that scale, it didn't only gauge the damage but also the wind, the speed of the wind. So as it goes up from F0 to F5, the wind would increase as well. So the first way to track and gauge these storms was obviously the F scale, or the Fujita scale, but they assigned, and it's still used today actually, a rating based on the worst damage along the tornado's path. However, the original Fujita scale was replaced in February 2007 with the refined and improved enhanced Fujita scale. The abbreviations for that are just the EF scale, and as you can see here on the EF scale, or rather it's a table that F scale converted to the EF scale. The numbers actually they vary a little bit. The EFO compared to the FO, or the F0 rather. The F0 were 45 to 78 mile per hour winds, and the EF0 were 65 to 85. Similar, but for whatever reason they changed this around. And so you can see in this graph the comparisons. As the years went on, they continued to use the Doppler and the radar and these scales to gauge tornadoes, and they could see patterns and consistencies. But today's forecasting, you see the continued research and advancement in computer technology from the 1960s through the 1990s, and it's improved severe weather and tornado forecasting tremendously. Meteorologists were soon able to develop numerical weather prediction models and technology. Again, the Doppler radar, huge development. The development, training, and deployment of the Doppler radar from the research world into the operational areas of meteorology proved to be the next boost in severe storm and training, or rather tornado forecasting, I'm sorry. As meteorologists became more and more familiar with the Doppler radar, they were able to not only detect areas of precipitation, but also to detect wind circulations that may develop prior to a storm producing a tornado. As you can see in this diagram, there's some arrows pointed at potential wind circulations that have the potential to develop into a tornado. So in response to these, a lot of times our meteorologists and through the news stations will issue tornado warnings or tornado watches, and it allows the viewers and the people that are in those target areas to at least take shelter, and it's a warning that it's huge in comparison to the early 1900s when there was none of this technology, and it was just it blindsided people, and that's why the death toll was so much more then than it is now. And again, the warning, I think, is the most critical part of the research and development that we've made in tornado research and tracking. Today, the National Weather Service has improved warning lead time to an average of 15 minutes before a tornado is reported. So obviously, 15 minutes is a substantial amount of time to be able to maybe not necessarily evacuate an area, but at least seek shelter, get to the safest place in your home, and again, later on in the presentation, we'll see how these numbers just trend downward as far as fatalities and so on and so forth because of the warnings. So I think just quick data forecasters and researchers have at their disposal in fractions of a second of a varying array of this data that were hand plotted just 40 to 50 years ago. So things that people literally plotted by hand 50 years ago, now click of the finger on a computer and we have that same data that allows us to see so much more, so much quicker, and as a result, this is what allows us to be able to be warned by meteorologists and news stations. So the hard work, dedication, and knowledge of many scientists all played key roles in advancing severe storm and tornado prediction through 70 years of research and observation. On the horizon is the development of the phased array radar. This new technology will allow researchers and forecasters to analyze storms with much faster electronic scans, leading to improved knowledge of thunderstorm and tornado development, and ultimately even better warnings in the future. I think this hard work over the past 70 years has paid dividends for us today, in that we don't have the same worries and concerns that they may have had 70 years ago with regard to these storms. So what I'd like to do next is just show you guys a few graphs that actually have the numbers and the proofs kind of in the pudding there, the improvement that's been made in tornado research. And we'll take a look at death tolls and the trends on a graph there, and then also just the warning time, how it's increased over the years. So let's take a look at some of those. And this is a quick graph of the U.S. tornado deaths from 1875 to 2010. Just collected data, and as you can see, really what I like to look at is from about 1923, that real high number, which I think that was obviously the most deadly tornado in U.S. history. But you can just look at the graph, and you're gradually trending downward, ranging from, almost 800 deaths in 1925 area, all the way down to, you're down to less than 100 or so in 2007. So obviously, by this graph, you can see that we're trending downward in casualties due to tornado. Here's another quick example of some of the U.S. tornado fatalities. And again, you can see from 1940 there, you go just straight downward as far as numbers. Varies a little bit up and down, but you can tell that it's been greatly reduced because of the research and tracking that they do now with the tornadoes, the warnings that we have. I think that's the big topic the warnings, which is what we'll discuss next. This is a graph from 1986 to 2014. The National Weather Service issued United States tornado warnings. And this is just from 1986. I mean, you can see the amount of warnings that were given as the years increased, which allowed U.S. residents the opportunity to, one, know that these storms are coming, and then two, they have an option to flee to safer areas. So you can see in this graph it's just gradually trending upward, and the number of warnings that we have now are much greater than they were in the past, which allows us to be able to do what we need to do to get away from these storms. This final graph we're going to look at, it's just tornado warning lead times. Shows how much larger the lead time has become over the years. From 1995 to 2010, you've got 95, 10.2. That's in minutes. So you're looking at 10.2 minutes of reaction time from the time the warning comes out until the actual tornado hits. So 14 minutes as opposed to 10 minutes. 4 minutes is a long time when things like this are going on. So you have more time now to react because of the research that's done, and they're able to predict more accurately and more efficiently. So that lead time has been huge in tornado warnings. So definitely appreciative of that. All right, well, in conclusion, I think it's obvious to see that the United States of America has greatly decreased the number of fatalities from tornadoes over the years. And along with the decreasing number of fatalities, we've increased the warning time, and this ultimately allows people more time to prepare. So I think in my studies I found that the research and tracking that's been done over the last 50 years has helped us. So thank you.